Okay folks, so here's lesson 3 for matrices. So what we're going to start with doing is calculating the determinant of a 2 by 2 matrix. Now this is a new word for you, you've never heard of the determinant probably before. It's basically, if you find out the determinant of a matrix, it gives you a number, okay? And that number can help us in order to find the inverse of a matrix. That's really what it's for, okay? You also need to have a square matrix, so like a 2 by 2 or a 3 by 3 or 4 by 4. And so on. Okay, so take the heading, the determinant of a 2 by 2 matrix. Just going to write a quick note about it first of all. So this is a value representing sums and products of a square matrix. Okay, so the determinant just gives you a single number of a square matrix, pretty much. Okay, so if A equals, I'm just making this up, so A, B, C, D. Okay, so here we've got a 2 by 2 matrix. Then, the way that we write the determinant is just det A. Det A. That just means the determinant of A. Okay, and you could also write it as like straight lines. Okay, so a bit like the modulus, so like A, B, C, D. So if you see those two straight lines, that just means the determinant, or if you see det A, that's just the determinant as well. And the way that we're going to work this out is you take your first diagonal, which is A and D, and multiply them together. So it's AD, take away the multiple of your second diagonal, so B times C just gives you BC. And that's how you work out for a 2 by 2 matrix. So your first diagonal multiplied together, take away your second diagonal, and that's just going to give you a number at the end of that. Okay, it's straightforward as that, but it's a major part of matrices that you will need to know pretty much. Right, so let's go through one example. So example, just going to underline that. Alright, so number 1, find, just doing blue pen. So find det A when A equals -1, 2, 2 minus 3. Okay, so we've got our matrix A. It's a 2 by 2, it's a square matrix, which is what we need. So det A is just going to be equal to your first diagonal being multiplied together. So I'm just going to show working for this, right? You don't have to, you could just write -1 times -3 gives you 3. So I'm just going to show working. Oops. You could just go straight to writing 3 if you want. Take away your second diagonal being multiplied together. So 2 times 2 is obviously 4. I'm just going to show working. So you should have 3 take 4, which gives you -1. Okay, so your determinant for this for this matrix A is just -1. So first diagonal, take away your second diagonal. Right, on the next page, what I've got here is a bunch of questions that I would like you to work through. So pause the video at this point, take a screenshot. Can you work through these 5 questions to work out the determinant of all of these? And I'll reveal the answers in a few seconds, okay? Okay folks, so here are the answers. Okay, so if you're not getting any of them, just let me know please. Okay, so that's the determinant of a 2 by 2 matrix, right? Next one we're going to go on to is do the determinant of a 3 by 3 matrix. So determinant of a 3 by 3 matrix. Okay, so we're going to stick to square matrices here. Okay. Right, this is where I want you to pause the video and make sure you've got your formula sheet in front of you because that's going to help. Okay, so on the next page, so here, this is just the second page of the formula sheet. Okay, And what you're going to be looking at in particular is this bit here. Okay, so I know it says the vector product, but this also helps us to work out the determinant of a 3x3 matrix. Okay, so what I'm going to do is I'm just going to actually take a screenshot of this and then stick it in my notes josser so it saves me copying it out again. Oops. Okay, and that is how we're going to work out the determinant of a 3x3 matrix. Thank God we've got the formula for this. Okay, so I'm just going to write a wee note here, given in formula sheet. Okay, so given it in formula sheet, this is the formula we're going to use. Okay, so can you pause the video, make sure you've got this formula copied in, like put a bubble around it, highlight it, just so you remember. Okay, and then once you've done that, let's go through an example and I'm going to show you how we're going to use this formula to work out the determinant of a 3x3 matrix. So example. Right, number one, so find the determinant of and it is b equals, so 2 minus 1, 2, minus 3, 0, 1, 0, 1, 2. Okay guys, so that's your question there. So if you ever have to work out the determinant of a 3x3 matrix, always go to your formula sheet. Now on your left hand side here, we have got a vector, it's part of the vector product, but can you see it's still a 3x3, look, so it's 3 down the way and then 3 across the way. Right, so it's still a 3x3 matrix. Okay, so what we're going to do is wherever you see an I, that's like the top left part, is going to be 2 in this case. So your I here is your 2, and then your J is the minus 1. So you can see how it fits in. Your K is going to be your 2 in here, and so on. Alright, so your A1 would just be minus 3. So wherever you see an A1 in here, you change it for minus 3. So we're pretty much like just copying this basically and writing down the formula. So if we get started here, so I got a pen, so I'm going to write here det B, because that's what we're working out. Okay, so the formula starts on this side here. Okay, you don't need to write it on the left hand side. So it starts with a capital, not capital, it starts with a small letter I. So that's the top left part of your matrix. You go to your top left part and that's 2. Okay, so I is going to be 2 in this case. Then it's got your straight line, and then the top here it's got A2, A3. So if you look here, A2 is the middle one, and A3 is the one next to it. So the middle one is 0, the one next to it is 1. And then B2, B3 are the bottom right two there. So it's going to be 1, 2. Take away, and then we've got J, which is going to be the top middle one. So the top middle one here is minus 1. Straight line, and then A1, A3. So A1 is the middle row, first one, A3 is that one, so it's going to be minus 3, 1. Then we've got B1 and B3. So B1 is the bottom left, B3 is the bottom right, so it's 0, 2, and so on. Alright, so hopefully you're getting the hang of this now. We've got plus K. K is your top right one, which is a 2. And then we've got A1, A2, B1, B2. So it's just the bottom left square. So it's going to be minus 3, 0, 0, 1. Okay, the only mistake people tend to make at this line is just the middle part, because you get I, J, K, but just make sure the middle one's a takeaway. It's minus J. Okay, they're not all positive here. So that gets you your first mark, and you might think, oh my god, this looks so messy. But don't worry, okay? So we're keeping the 2 out the front. Now remember I said in the previous example, those straight lines mean your determinant, and now we've got a 2 by 2 in here. Right, so what I'm going to do is open brackets, and then those straight lines, we're going to work out the determinant of this matrix in here. So it's your first diagonal, 0 times 2 just gives you 0. Take away your second diagonal, 1 times 1 is just 1. Okay, then obviously 0 minus 1 just gives you minus 1, times it by 2, etc. Right, here you've got a double negative, let's change that to a plus. And then in brackets, let's work out the determinant of this. So minus 3 times 2 just gives you minus 6. Take away your other diagonal, which is 0. And then last part, so you get 2 at the front here. First diagonal is going to be minus 3. Take away your second diagonal, which is going to be 0. Okay, so let's tidy this up a little bit. So 0 minus 1 is just minus 1. Times by that is just minus 2. Here you've got minus 6 take away 0, which is just minus 6. And then here you've got minus 3 take away 0, which is minus 3, times it by 2, which is minus 6. Okay, so that leaves us with minus 2 take away 6, which gives minus 8. Take away another 6 is minus 14. Alright, so your determinant should always give you a number as your final answer. Okay, and so the 3 by 3 determinant is given straight from your formula sheet. Alright, so same again. Actually, I don't have any questions for you to practice on this. That's fine. Right, what we're going to do is we're going to go on to, right, hold on, inverse. That's your determinant of a 3 by 3 matrix. Let me get the answers for you. Questions, sorry. I forgot to put them in. Okay, so here are your questions. So put them in for you. And I'll just get the answers. So it's number 22. Okay, so here are your questions. And your answers. Okay, so if you want I can just hide them now even though you've seen them all. Okay, so your determinant of a 3 by 3 matrix is here. Okay, so use your formula sheet, pause the video, get the answer to all of these, and I'll just show you the answers in a couple of seconds. Alright, so you've seen me before anyway, so here are your answers for them. Just please make sure you're using a formula sheet to get the correct answer because these are easy marks. Right? It's just given in a formula sheet. Alright, okay, next part, what we're going to do is we're going to work out the inverse of something. Okay, let's go back to that page. Okay, so once you've done those examples, working out the 3 by 3 determinant, you just want to write in a wee note in here. So can you copy this in just underneath that example? Note. So a matrix is singular if your determinant, so I'll write det A, equals 0. Okay, so that part's pretty important. There are a few exam questions that say why is this matrix singular, and then you'd have to work out your determinant and then prove that it equals 0. Okay, so the way that I remember this, it's a stupid way I've got, is if something is singular is single, it's going on 0 dates. Stupid, but 0 dates. It's single, hence your determinant, your det, kind of looks like date, equals 0. Okay, so make sure you've got a wee note of that, but put a bubble around it, highlight it, because that part is important when we go on to the exam questions. Alright. Okay, next part is we're going to work out the inverse of a 2 by 2. So these are your questions here. Let's go on and do the note first of all, obviously. So inverses. Just underline this. Okay, so if you copy this in, so an inverse exists for a matrix satisfies these two conditions. Okay, so for an inverse to exist, it must satisfy these two conditions. Okay, so number one, the matrix must be a square matrix. Okay, so very similar to the determinant. It must be a 2 by 2 or a 3 by 3 and so on. Okay, so the matrix must be square. Just go in 2 by 2 or 3 by 3 and so on. Okay, so if you don't have a 2 by 2 or 3 by 3, the inverse and determinant will not exist. Okay, second part is the determinant is not equal to 0. Okay, so we've already worked out that if your determinant is 0, that means that the matrix is called singular and the inverse does not exist. Okay, and you'll see why it doesn't exist if it's 0 in a wee second. Okay, so like if a question says to you, prove that the inverse does not exist, you would just work out the determinant and then you would get 0 and it doesn't exist, pretty much. Okay, so if we say let A equal, we'll just do a 2 by 2, so A, B, C, D, then the inverse of A, so it's just A with 3 minus 1 at the top, right, equals, so at the front here we've got a fraction, so it's always 1 over whatever your determinant is, so obviously AD minus BC. So det A, open brackets. Right, then what tends to happen here is, see your first diagonal, they swap places, okay? So A and D swap, so I've now got D and A there. And then your second diagonal, they just change sign. So they stay where they are, but if they're a positive, they would just go to a negative. So you get minus B, minus C. And that's the formula, how you work out your inverse of a 2 by 2 matrix. And it's not given to you in the formula sheet. So I'm just going to write in here, not given in formula sheet. Okay, so 1 over your determinant, hence why your determinant cannot be 0, because you can't get a 0 in the bottom of a fraction. Your first diagonal swaps places, and then your second diagonal just changes sign. Alright, so I'll show you one example. Okay, so number 1. Find the inverse of A, so A, 3 minus 1, when A equals minus 2, 2, 3, 4. Okay, so first of all, let's do a wee check. Right, I've got a 2 by 2 matrix. Good, it's a 1 square matrix. Okay, we're going to find out the inverse of this. So the inverse of A, remember it's 1 over your determinant. So if we just go ahead and work that out, so your first diagonal multiplied together, so it's minus 2 times 4, gives you minus 8. Take away your second diagonal, so 3 2s are 6. Okay, so obviously that will simplify down, right? And then your matrix here, your first diagonal swaps places, so minus 2 and 4 swap, so 4's up there and minus 2's down there. Your second diagonal, they just change to a negative, or change its sign. So it's going to be minus 2 and then minus 3 in there. Okay, obviously let's tidy this up a little bit. So here, minus 8 take away 6 gives you minus 14. So out the front here you've got minus 1 over 14. Inside the bracket can stay the same. Now you might notice here we've got a lot of negative signs here. This is actually correct, right? You're going to get full marks here, but if you do want to simplify it further, what you can do is you can multiply the minus 1 by everything here. So what you just get is 1 over 14, and if you multiply everything by the minus 1, it gives you minus 4, 2, 3, 2. Just change the sign of everything, and that's also correct. Okay, so you'll get the final answer at each of those stages. Okay, so the hardest thing here is to remember that formula. It's 1 over your determinant. First diagonal changes places, and then your second diagonal changes sign. Okay, so here are some questions I would like to do. So pause your screen at this point and I'll show you the answers in a wee second. So all of these are just working out the inverse of a 2 by 2 matrix. Okay. Okay, so here are your answers for these. So you would get full marks at either stage. You don't need to multiply through by the fifth like they've done in the answer here. So you would still get full marks like at this stage here. Alright, and the final thing that I would like to go through today is what's called the identity matrix. Okay, so identity matrix. Okay, so we call this the identity matrix like a capital I. Okay, just like this. And it could be, so it's got to be a square matrix, but it could be any size of square matrix. But what happens is that your diagonals are always 1, and then you fill in the gaps with zeros, just like this. Right? So for example, if it's a 2 by 2, if you've got a 3 by 3, you'd have 1, 1, 1, and then you'd fill in the gaps with zeros. Okay, and this is just like the number 1 of matrix form. So if you multiply anything by the identity, you're just going to get what you started with. Okay, so it's just the number 1 of matrix form. So if we say in the previous example, so we said that A was minus 2, 2, 3, 4 in the previous one, and we figured out that A minus 1, so the inverse of A was, I'll do it minus 1 over 14, 4, minus 2, minus 3, minus 2. So taking the unsimplified form. Okay, so that's what worked out in the previous example. Right, so if I multiply these two together, right, so if you take A and you times it by the inverse of A, right, have a think of what would happen. Like if you times like number 5 by the inverse of 5, you probably know what's going to happen, and I'll show you that here just very quickly and then that'll be done. So if we have A, which is 2, 2, 3, 4, and the inverse of A, multiply it through by negative 1 over 14. So that's going to give me negative 4 over 14. I know that's negative 2 over 7. And then it's going to give me 2 over 14, and then 3 over 14, and then 2 over 14. Right, think back to lesson 2 when we did multiplying matrices. So if you've got the first two multiplied together, so what we're doing is multiplying together. So your left finger's on the minus 2, your right finger's on the minus 4 over 14. If you times them two together, what you're just going to get is 8 over 14. This one moves to the right one, this one moves down 1. So 2 times 3 over 14 just gives you 6 over 14. Okay, so that's your top left. Your top right, minus 2, and your 2 over 14 just gives you minus 4 over 14, plus this one moves a long one to the right, this one moves down. 2 times 2 over 14 just gives you 4 over 14. Okay, right, bottom row, 3 times minus 4 over 14 just gives you minus 12 over 14. This one moves a long one, this one moves down. So 4 times 3 over 14 just gives you 12 over 14. And then final one, you've got 3 and then the 2 over 14. So that just gives you 6 over 14. This one moves a long one, this one moves down. So that's just going to give you 8 over 14. Okay, so if we work through this, so if you add these together, so 8 add 6 just gives you 14. This is 14 over 14, which is just 1. Top right, if you get minus 4 over 14, add this, that just gives you 0. Here, if you get minus 12 over 14, add 12 over 14, that just gives you 0. And then here, 6 over 14, add 8 over 14, gives you 14 over 14, which is just 1 whole. Right, so can you see what we're left with? So if you multiply anything by the inverse of itself, that gives you your identity matrix. Okay, so that part's important, and we'll come back to that later on. Okay, so what I'm just going to write in here is 3 wee dots, and then a times a to the minus 1 equals your identity. Okay, and that's quite an important part later on, so I'm just going to put a bubble around that, and then that is lesson 3 finished.